I'm here. I feel like I'm speaking in the speaker corners in the Hyde Park. You know, the room is so big and everybody's so spread out. I hope you can hear me back there. Okay, that's great. A little bit about me. I'm Utpal Thakrar. I'm a product manager on the product management team. RightScale, primary responsibility is around integration of clouds. So I look after the area where we integrate with a bunch of clouds, public and private, and make sure our platform works well together. So needless to say, we're going to talk about private and hybrid clouds today, and we'll go over some of the key considerations that we need to keep in mind when designing those clouds, and why people do private clouds and why people need hybrid clouds, right? And this is something that is up and coming. It's not a well-baked scenario as you would see in the public clouds, but it's getting up there. So virtualization, common mistake. People think virtualization is cloud. So virtualization is the technology that enables you to use a single physical host, put a bunch of virtual machines on it, and leverage the power of the hardware, right, properly, and be able to get more out of your investment there. But it looks this way. People think they have cloud as soon as they have virtualization. What really happens here is virtualization is what enables the cloud technology, right? Without that, you won't have cloud computing, right? So the ability to create virtual machines on physical hosts and control them programmatically is what made cloud computing possible today, right? So it kind of looks like this. So public cloud. What exactly is a public cloud? And there are various definitions, and the most common one that we'll talk about here is it's hosted by somebody else. That's not you. It's somebody else who's hosting it. Supporting multiple customers like ourselves. It's not just us, right? It's multi-tenancy environment. Uses shared infrastructure. Typically used in a pay-as-you-go type model. It's a very utility-based model where you pay for resources that are used by you, and you use as long as you want, and then you get off, right? Kind of looks like this for the most part. It's maintained by somebody else. It's supposedly fast. It's on time, and it's supposed to work, right? At times it looks like this too, right? Because it gets crowded, capacity issues, there are outages and that sort of thing, right? So we have to deal with it. Or you can have this. This is yours. This is all yours. Have it your way, but at the same time, you take the ownership of maintaining it. It's your responsibility to keep it up. It's yours, a single tenancy. So you better have a very good reason to do this, and we'll go into those reasons as to why one should be doing this, right? So what is a hybrid cloud? So there are various definitions that float around, right? People talk about hybrid clouds. I would define it as use of multiple private or multiple public clouds, or have a virtualized environment, for example, a dedicated environment mixed in with another cloud. I would call that hybrid as well, because that's getting there right now. There are some use cases that we'll go into which squarely fits into that model. And essentially, we are extending the definition there. So it's kind of like this. You get best of both worlds. You use your private cloud as long as you ride to the place where you can catch your public transportation, and then you ride the public transportation the rest of the way, right? So it's kind of a mix of both, right? All right. So we got the definitions out of the way. So this is where we were. How did the infrastructure evolve over time, right? Old school data center, everybody was happy in the 20th century, partying like 1999, right? There was no worry, there was no cloud, nobody cared about anything, right? Data centers were there, single applications was running on the hardware, and IT was happy the way it was, right? Then came virtualization, and VMware filed their first patents in the late 90s around virtualization. Although the technology has been kind of there more or less even in the 80s, but this is where it started getting more formal, right, in the 2000s. And then came the hippie days of cloudification when Amazon had excess capacity that they wanted people to start using. So they leveraged virtual technology, virtualization technology. They exposed it with APIs, and now all of a sudden you had a programmatic access to their resources that are there was excess capacity for them, right? It was, happy-go-lucky, merry times for everyone, and the cloudification, the whole principle came into limelight, right? And now we have sophistication. Now people are more discerning. There's a lot more going on there. And yeah, I am a Star Trek geek here, so excuse me for that one. So why do people use cloud, and how difficult it is for organization to adopt cloud, right? And this kind of speaks to that, right? When we talk about clouds in a way that an IT person thinks that his job is at risk, or it goes squarely against everything they've believed in the past, it's kind of like this, right? So what we really need to do is whenever we think of clouds, whenever we think of public or private clouds, right? When introducing a cloud to an organization, we have to go with an end in mind, right? So here are some statistics from a company called Everest Group here, and they did this presentation last year at another show, Cloud Connect show. So here, as you can see, there are various things that they measured, right? And cost was one of them, right? However, there were other factors that were actually turning out to be more important, and this one in particular is the flexibility of the infrastructure. So how people consume IT is changing as a result of having cloud in your infrastructure or part of your strategy, right? So people go in, when people think of cloud, they think of utility computing and they think of cost. They go, it's going to reduce my cost. But that's not always the case, right? So more people, like 82% actually said, our goals were to actually make the infrastructure more flexible and easy to consume for our users, right? Similarly, there is another one which is on agility and how that seems to be the key concept that people are going after. It's the ability to get the ability to make the infrastructure available to their users quickly so that the business can go on quickly without any hurdles, right? So as you can see here, the TCO is actually pretty low on the list there. So why would you build a private cloud, right? So there are various factors that one need to keep in mind, and this is actually a pretty important area to discuss. People have different workloads, right? There are certain workloads that are not going to be suitable for public clouds. So I'll give you an example. So when you think about big data and analytics and running Hadoop on a public cloud, it's not always easy because the kind of virtualization that you get, the kind of virtual machines that are available, the kind of disks that are available in the public domain today are not necessarily conducive to the workload that Hadoop requires, right? So for that, you either need to tweak the software and have a special version of Hadoop, or you build your own, right? You put it in your infrastructure where it's closer to the bare metal, very lightweight. You can put more powerful machines around it and powerful storage systems around it. So things that require very specific type of hardware configuration, those are suitable for a private cloud workload, right? Security and regulation and compliance. So the previous session, you guys probably heard a bunch about security and compliance. A lot of things cannot go outside the four walls of a particular organization, right? And maybe that is changing. Maybe it'll look different in the next 5 years. But today, that's the case, right? Banking industry, health industry, they are very, very wary of putting stuff out in the public clouds, right? So security, compliance, regional biases as well. So certain, for example, certain European countries like Germany, the data that belongs to the subscribers in Germany cannot leave the country. It has to stay within the country, right? So geographical restrictions for compliance. These are the reasons why people end up building specific private clouds just to house the data that they need to be in the private cloud, right? Latency is another big issue. So let's say if you are a user in India trying to ping a server in AWS data center on US East, right? And it takes 300 milliseconds ping time. right? That's not going to be acceptable to anyone. And as my friend here can testify, we've seen those kind of things where people get really frustrated over the user experience, and they want the infrastructure and their application closer to where the users are going to be, right? And just to reduce the latency and improve the user experience there. So those are the reasons why you take your application closer to the user. If there is nothing else available, there's no public cloud available in that area, you end up building a private cloud there, right? And cost is another factor. Now, as I said earlier, cost is not the only factor, it's one of the factors. And the way it works out in the end is if you measure your utility, let's say if you have a steady workload that you take to a public cloud, right? And you continuously run that for a year or 3 years, right? A steady workload. The utility computing will actually turn out to be more expensive than investing that in your own infrastructure and running it and running the operations for it. So, of course, there is a capital expense versus the operational cost issue, where you're paying there on a rental basis versus you're owning the infrastructure yourself. So there is a little bit of difference as far as a CFO is concerned. They may have a bias against one or the other, but in the end, a private cloud for a certain type of steady workload may actually turn out to be cheaper. So that may be one factor. The other factor is, with any cloud computing comes the agility, and that actually helps reduce a certain amount of cost. So that's another reason. Okay. So when would you need a hybrid cloud or a multi-cloud environment, right? So in some cases, okay, now you're happy, you have your private cloud up and running, it's great, right? But you still have the finite amount of resources that are out there, right? So you heard probably in the keynote where they were worried about the success disaster, where Samsung was talking about that. If that happens and your application outgrows what you have available, now all of a sudden you need to either put a new hardware in there in a hurry, or you figure out another way to get into a utility computing model, right? So that's one of the reasons why you want to go into cloud bursting. It's not as easy as people may think. It seems like a panacea, but it's not really. We'll talk about that in a second as well. But that's one of the reasons why you would go into a hybrid cloud model. As I was talking about earlier, a lot of times there is a restriction around what can be in a private environment or what can be in a public environment. So for example, your database, which contains the data, needs to sit in the private environment versus other things that are more stateless can go into a public environment. Of course, there's security issues when the data is in flight between the two environments, but that needs to be resolved somehow, right? Most common use case that we've seen so far is a single large organization would have multiple departments or multiple business units that are using clouds differently, right? So they're using one department may be using Amazon, the other may actually have a specific need and use their, create their own private cloud there in the environment. There's also a situation where people have existing hardware that they want to leverage, right? And they want to start using that, repurpose it and start using it as a private cloud. So all these different things, but typically a single application would reside in a given cloud. So while we talk about multiple clouds, people have multi-cloud strategies and they want to be able to expand across multiple clouds. So far the use cases have been kind of narrow, where they limit themselves to a single cloud for now, and they figure out like, okay, I need the option to go to the second cloud if need be, right? In some cases, they are not sure whether they like this particular cloud provider. Either they are too big or they're too small or whatever the reason may be, right? But they want the flexibility to be able to move, right? So those are all good examples of why one would need a multi-cloud environment. So a couple of use cases. So I'll go through a couple of use cases here. This one is, you probably saw this diagram earlier in the keynote where we were talking about cloud bursting and having a specific tier in a 3-tier application go out into the public cloud, right? So the stateless part, this is typically, if you can't read from the distance, I'll read it out. This is the load balancer tier, this is the application tier, and then there is the database here, right? This is a typical 3-tier application. Now, the load balancer and the app servers are typically stateless, and the state resides all in the database, right? And this is the easiest to burst out, because now you spin up another server, and as long as this server has connectivity back into this, you're good, right? The only thing you have to worry about now is, and it's actually quite important, is the latency between the two, right? Yes, it can reach, so it has access. Now all of a sudden you have service availability, but the service quality may suffer as a result of the latency, right? And there's also security concerns between the channel across these two elements. Does it make sense? The second use case here is untested workloads. And the way this works, and this is based on years of our customer experiencing it this way, is where they are starting out with a new application, or in some cases a new game, right? We have a lot of customers who are gaming providers, gaming software writers. They use the public cloud and the utility model to actually test this out, right? And figure out where they stand, whether this is going to be successful or not. Before making significant investment in their infrastructure and bringing it in-house, they want to make sure that they understand the workload patterns. And then based on that, eventually once things become stable, they'll bring it in-house, and then that's where they realize the cost benefits, right, of bringing it in-house. So those are the untested workloads. In some cases, the application just goes away. It just dies, right, and that happens. In that case, they don't really necessarily lose anything as far as the investment goes in putting it in-house and creating a private cloud for that. And this HA and DR scenario using the hybrid cloud is another good use case for that, where you have a private environment and a public environment. And this describes a little bit of a warm scenario, warm DR scenario. And what by that what we mean is the data is replicated, but the applications are not. So you have everything running in your private cloud is humming along. You're constantly replicating data elsewhere to a public cloud environment. And in the event of a disaster, your private environment goes down. You fire up the servers, fire up the application servers on the public side, and the data is already there. So there is some amount of latency that happens as a result. There's finite amount of latency and speed of light, laws of physics, whatever you want to call it. So there is a certain amount of data loss possible as a result of this type of environments, right? So again, the whole HR and DR discussion is around a dial, right? The more you spend on it, the better you'll get. The RTO and the RPO, as we know it. Those are the times that are very important. Like at what point can you afford to lose data, or how much can you afford to lose data, right? Can you lose 30 minutes worth of data, or can you lose 10 hours worth of data, right? And depending on that, your cost dial will vary, right? The other issue here is encryption between the two. The channel is typically on the public internet, and that you need to take care of that through some level of encryption there. So we work with a partner typically. The company's name is Cloud Optimizer, and the product is called Cloud Ops. And they do a pretty good job at encryption and reducing the bandwidth cost by compressing the data. So bandwidth cost is a factor, latency is a factor, security is a factor. So it's all about balancing, right? It's all about mitigating the risk of your downtime and designing your DR solution around this, right? So this is another interesting example, and you saw Samsung talk about this earlier today, where they're using Rackspace. Well, they're not using Rackspace, but it's similar. So Rackspace and RackConnect are two different terms that are used by two different vendors. AWS calls it the RackConnect, and Rackspace calls it RackConnect. Very similar concept. Conceptually, they have a cloud environment, like an availability zone or a region, and right next to that, very, very much in physical proximity, is the private environment where there is dedicated hosting going on. right? So you imagine your private environment being in that, and then a public environment right next to it, right? Now that's, and the connecting technology is either Direct Connect or RackConnect. They are, if you squint and look like this, they all look the same, right? They're about the same. Now the situation there is that now you have to find a provider, either Rackspace themselves who offer you this dedicated environment, or another provider in case of AWS, it could be CoreSite or Equinix, or there are 10 others, right, that have the facilities that are in proximity to a public cloud. And that's great. It may happen for 1 or 2 regions. You may have that ability in the US. What about elsewhere? What about elsewhere in the world, right? So that's a challenge unto itself. However, this gives you a lot of benefits around the three or four issues that we talked about earlier, which is latency is lower, right? You are expected to have a more secure channel between the two environments. So security is kind of mitigated there. Latency is mitigated, and you can have actually a private environment almost, right, between the two. So it's actually pretty good. The cost is lower because Direct Connect and RackConnect, they both don't charge for the bandwidth fees, as far as I know, and that reduces the cost. In the other environment, you have bandwidth costs no matter what, right? Because all public cloud providers have this model where they charge you for the egress traffic that's going out, and the incoming traffic is free. So that's an interesting model. We have a few customers that are actually experimenting with this type of model, and they're quite happy with the results there. The last thing here I want to point out, and that's a proof of concept that Rackspace is working on right now, called the Metro Area Network. And the goal there is to have separation of these two physical locations by about 550 miles. So that'll give more options all of a sudden. Once that happens, they're working in conjunction with other network providers and so on and so forth. But once that happens, then we'll have more options as to, you don't need to be like, chained at the hip, so to speak, with the public cloud providers there. Okay. This is the diagram that, the complicated diagram that you probably saw during the keynote, if you recall, and it's pretty much describing that. What Samsung has done is they have redundancy everywhere. So they have these links between the two environments, and those are provided by different service providers. Because if a service provider goes down or they go out of business, they still want to have that connectivity. And same with here as well. So they've put a lot of money into this, or they're actually in the process of putting a lot of money into this. It gets very expensive. Yeah.
Where is RightScale running in this?
So RightScale hovers about that. RightScale essentially provides the management interface across both of these clouds for the applications. Right? It's not particularly about cloud management at that point. It's about application management, right? So this is just describing that there is 2 clouds running different VMs, and they're connected in a certain physical way, right?
So the RightScale connectivity to these VMs, that doesn't matter. The RightScale can run on different traffic?
Sorry. RightScale runs here at the top.
And connectivity between the RightScale and to these VMs here and that VM, that's not of great importance.
It is important, but it is typically control panel, right?
Can you repeat the question for the camera, please?
Yeah. So the question was, where does RightScale sit in this picture? So this, what I was saying is, this is describing the physical layout as to how the 2 clouds are set aside and how they are connected with redundancy there. RightScale hovers above these, manages the VM, fires of the VM. It's that at the application level, right? The connectivity between RightScale and any of these clouds is actually, it's important, but it's not that significant in the sense that it's only really, it's not in the data path, right? It's in the control plane. So you're actually starting the VM, you're getting out of the way. So RightScale is not really involved in any application transaction per se, right? It's just a control part of it. Does that make sense?
It makes sense, but I would say in terms of like real HA, I would like RightScale's tentacles to go actually into both of these.
Yeah, it does. It does.
Not just via write images. with some kind of controllers, right? What happens if the internet traffic is spiky, right? I don't have I have high because the internet traffic is like sorry. It's complicated.
Yeah. So I've kind of controlled my.
I was going to repeat that. Are you kidding me?
I've put significant money to build that private network and put the direct connect and everything.
Right.
But being the controller, I'm concerned about the controller also, right? The controller is the master now, right?
Yeah.
And it's not in the data path, but that's where I'm getting all the alerts, all the orchestration is happening. And if that orchestration does not perform due to latency or due to network disruptions, that's a big problem, right? I mean,
right. Right. So there is a, and I'll talk about this in a little bit. There is a design consideration there about keeping the management layer separate from your actual payload, so that you essentially, if one of them goes down, you still have either your application running humming along, and if the cloud goes down, then your management layer is above that and is able to spin things off in a different way, right? So what you're talking about is actually an interesting point. I don't have a good answer for that right now, in terms of what can we do to actually get closer to the cloud and make it more secure for certain application workloads like this, where they've already poured a lot of money into keeping their environment really nice and tight, and we are actually in a SaaS environment where, you know, there is some expectation of security because we always do SSL between our connectivity to the cloud, but there is variability there in terms of latency, for sure. So what we do is we have customer accounts are divided across variety of, so we use it. I'm going to be, you know, transparent about this. We use AWS for our SaaS model, where all of our RightScale runs on AWS today, right? And accounts that are closer. So, for example, if you have a Japanese customer and their cloud account is in Japan, their account and all their related data is going to be closer to in the Japan data center of AWS, Japan region, and so on and so forth. So we try to divide up our accounts in different regions so that they are closer to the cloud that they are managing, right? So it's not guaranteed, but it is a best effort in that case. We are closer to that cloud. So, coming back to the real topic, which is the considerations of how do you design a private cloud, right? What are the things that you need to look out for? Hardware considerations, of course. Typically, people want to, it's like a conflicting goal there, right? People want to use commodity hardware, want to squeeze cost out of it. At the same time, they are designing the private cloud for a specific purpose, and that purpose could be, my application requires is a storage hungry application, or requires extreme high bandwidth I/O, right? Or requires a really high powered CPU. So you can use commodity hardware if it fits your application. So again, design the cloud with the application in mind, because this is a single tenant environment, right? If you are going to build a Ferrari just to go to the post office, it doesn't make sense, right? You probably need a bicycle at that point. So design with the application in mind, right? This networking is another big deal, because networking, once it's set and once you have your application running in a certain way, it's difficult to change, right? So there are different networking models that are out there. Different cloud providers have slightly varying models out there. So make sure that we have to make sure that we understand what we really need. Most of the single tenant environments are pretty simple, right? You don't need to worry about tenants encroaching on each other or significant security issues, right? But you also have to make sure that you keep the option open to have a multi-tenant environment in your cloud, because tomorrow a business unit may come up and may want to put their application there, right? Storage is another one. Typically, people have, this is a very important area, because people end up using SSDs for workloads that they need high I/O requirements. Software considerations. Of course, there are various cloud infrastructure softwares out there. OpenStack and CloudStack are the two that are the front runners right now. They both are very good. OpenStack has a lot of community momentum. CloudStack is actually a pretty mature product by itself, and we have a lot of customers on both, actually. Both of them are open source. This is the interesting bit where CloudStack recently, I would say about 8 months ago or so, open source became an Apache project, and there is a small amount of community effort there going on as well. Of course, for both of them, you can get commercial support. OpenStack has a medley of supporters that they are offering commercial distribution. They don't exactly match the trunk version of the OpenStack, but it is something that they would stand behind, and it takes a lot of guesswork out of that. Right? So, resources. When thinking about which cloud infrastructure platform to pick, you have to think about whether you'll get support, whether you'll be able to find people who actually understand this cloud, find enough documentation, and so on and so forth. The richness of the API, whether you can live with the user interface they offer for managing the cloud infrastructure itself. All of these are good considerations. Of course, nothing is steady. I mean, once you make a decision, tomorrow you find out that something new has come out in OpenStack or CloudStack or vice versa, and you can't keep chasing. So you kind of have to be stuck with it for a while. It's not easy to rip and replace. Choices of hypervisor. There's a variety of, and both at least CloudStack and OpenStack have support for a ton of different hypervisors. You have to pick what works for you. If you're looking for free, something cheaper, something that works basically, KVM is your thing, or you can pick Zen, which has been very stable and feature rich in our opinion. Finding a good home for the cloud, right? So it depends. It again depends on what is the purpose of building this cloud, right? If you're building to reuse some of your existing hardware and you have space like this where you can put racks in the back there, sure, you can just do it in your own data center facility, right? That's the on-prem stuff. Or you can find a co-location facility, and that's been the typical model. Most people have that, right? Or the third option being find something adjacent to a public cloud. If you have the hybrid cloud in mind later on in life, then you should pick one of those. It's actually important because making sure that the environment is secure, wherever you put, it needs to be secure because there's a reason why you chose to do a private cloud. It's network rich, where there's enough bandwidth and capacity available, and it's going to provide some level of SLA for you, right? So the implementation process, typically I would just put this as 4 high-level bullet points. Design, automate, monitor, and test, right? So when you design a private cloud, you have to, of course, keep the application in mind, right? You have to worry about what the application is going to do with the cloud and design it accordingly. The application may have certain requirements. We believe that application should take care of its own HA using tools like RightScale, but at the same time, there is another school of thought that says, why can't my cloud be HA, right? Why can't it be available on its own? While I personally believe that the application should not create dependency, like SLA dependency on the cloud, because now you can't migrate, because the next guy is not going to give you the same SLA. You can't take your workload there. But that's how it is, right? So people like to have HA in their private cloud environment as well. It's costly, and you have to do extra work for that, right? So in this case, I'm using the example of OpenStack, where there's a bunch of single points of failures. There's a bunch of ways to mitigate that. There's lots of technologies out there, and I'm giving some examples here where you can do cluster management. You can do pre-shrink wrap type private cloud products like Rackspace Private Cloud, which comes with HA. You just click a button and say, I need HA, and all of a sudden it'll make sure that all the right things happen and is installed in such a way, right? So of course, this is just a pictorial view of what an HA would look like. Essentially, you are avoiding single points of failure, and that's the basic message here. Right? Avoid single points of failure. Make sure there is a plan to automate things, where if there is a failure, you are able to recover from that by deploying something else rather quickly. Right? Network options, as we talked about earlier, both OpenStack and CloudStack have very similar looking models. And one is called flat DHCP versus basic zone, which is very similar for a single tenant environment. And then there is advanced stuff where you have multi-tenant environment, each tenant gets a private LAN and so on and so forth. Capacity planning, of course, capacity planning is important. I mean, if you have any of these things, then you don't need it. But most of us don't have the luxury of having infinite resources and teams of geniuses available at us. So, how do you plan for capacity? You monitor and you automate, right? You monitor how your application, how the application is using the cloud, and you have a plan to react to that, right? So if you see that the application is very erratic, it requires additional workload at peak times, either you figure out that you're going to burst it out to a public cloud, or you have spare capacity available. Automation plan, in the middle of the night, your machine goes down, it must come up and right away. You better have an automation plan ready for that, right? So you can't be doing this manually. There are various tools for monitoring. There's various tools for automation. These are some of the examples here. Chef, Puppet, Fuel from a company called Mirantis, works on OpenStack. It's a pretty good product. Monitoring, most of these things are open source, so there isn't a whole lot of cost involved. Access control and tenant management. This is all around configuring the cloud itself as to how you want your tenants to use it. And it's they have similar. I mean, CloudStack and OpenStack. I keep using those two as examples. There are many others, but I think they all follow similar principles as far as separating tenants and making sure that the resources are spread across them in a certain way, and there's access control around that. Separating the management layer, and this is what I was talking about earlier, this is similar to having your keys locked in the car like this. When so now you don't have the keys, the car is inside, and I'm sure there's a baby in here that's not shown in the picture. So this is my recommendation: connect your private cloud to RightScale. Here the two examples are with the OpenStack and CloudStack, very similar looking screens as you see. Basic things that you need to supply is an endpoint, which is the cloud endpoint for the APIs, and then the admin username and the password. Pretty much, that's all we really need to connect to that. It makes your application port across. So when somebody was talking about earlier in the keynote that everything has EC2 compliant APIs. How many of you think that's not enough? Just having the API syntactically compliant. It's absolutely not enough, because there are semantic differences between clouds that you can't get past, right? The API is comparable, that's great. So now your program will run against that, but so what, right? Because everything else is different underneath. So what we provide is a real portable solution where you can take your workload, you create it in one place, and you can migrate it across to a different cloud in a heartbeat, right? Pretty quickly. So that's one of the key value propositions. Always keep application in mind. I can't say this again and again, right? RightScale makes it possible through having reproducible and predictable ways of doing things. How many of you guys are actively using RightScale right now? Quite a few. So you understand what I'm talking about. Multi-cloud images, the ability to spin up servers and recreate them as opposed to migrate them is a huge difference, and it's a philosophy also, right? Because a lot of vendors allow you to migrate your workload, and that's a pain in the butt because it's a forklift. You're taking a massive amount of data or a large application, moving it across takes time, and it's not always reliable, right? It may not work actually on the other side. But it's what we do is we tear down, we recreate on the other side, and that's the RightScale way of doing it. This is another pictorial on the number of public clouds and the private clouds that we support today through our dashboard. And they all work seamlessly with pretty much the same server templates. In summary, how are we doing on time? All right. Got 10 more minutes. So in summary, private and hybrid clouds are here to stay. We have to get used to them. There will be applications where you will need some amount of private clouds, so don't be shy. Use other facilities like Rackspace, Equinix, CoreSite. All these are great players in that space. Once the technology gets to a point where a metro area hybrid clouds are possible, things will change dramatically. Right. Any questions? Yeah.
Wait. I have a job.
Thank you. Where do you see Eucalyptus today and in the next year or two?
How many of you are using Eucalyptus here? Well, there it is. There's your answer. Sorry. So we recently, so Eucalyptus hasn't, sort of the advent of OpenStack in the last year or so, this has taken off the community momentum and all. Eucalyptus is less and less in terms of what we see today. By summer, we'll probably not have support for Eucalyptus because we see zero demand on that right now, being completely honest here. So, yeah.
With the metro area stuff that you see coming down the pipeline, is the network interconnect different? Is it still layer 3, or are we talking about layer 2?
I don't know the details. There's a link that I can send around if you give me your business card. This is a research project that Rackspace is doing with Brocade. So I'm assuming it's level 2.
Okay, thanks.
Yeah. Yes.
I was wondering, how much demand are you observing for cross-cloud implementations? Sort of somebody that's customers that want to federate across. I guess federation is a better word. Maybe some portions with AWS, some portions with Google, their own VMware implementations. Sort of just the messy mixes.
Yeah. So nearly all customers, I would say, 75 plus, maybe 80% of the customers that come to us, they want that, right? They haven't really figured out completely as to how that will pan out or how they will orchestrate all that, but they come with that desire and say, we want multi-cloud, and hence RightScale would be the place to be, because now you can go across clouds without actually tying yourself to the underlying infrastructure. How many are actually doing it today actively? I would say a small portion is starting to do that, but it isn't the large majority yet. Although they all have intention. So when we do surveys, you probably saw some of the results in the keynote as well, where north of 75% was actually showing that they wanted to go to multi-cloud. Either they are doing it today or they want to go in the future. Yeah. All right. Well, sure. Yeah.
So I don't know, that's my experience, but what I'm seeing is basically the orchestration part is getting more complex even than the application. And sometimes I've seen the orchestration code actually grows maybe equal to the application code, right? Now, what my concern is, the orchestration code which the RightScale is running, how highly available is that? And I'll give you an example. Let's say I am building a cloud, right? And I have a script using write scripts to do step 1 to step 10, right? Now, what if the RightScale server, which is executing that script, it fails? Now, is that state maintained in the RightScale such that, okay, it knows I failed at this step, I need to resume from this step? What kind of okay? So I'm not expecting full details in terms of how you do that, but is that, because I don't see that documentation available on the RightScale.
Yeah. So so rather than getting into the details, I would highly recommend. There's a session on how RightScale runs RightScale on RightScale. Go to that. and you'll absolutely get the answer to that. There is HA, and we actually have an SLA to our customers as well. So I would highly recommend, if anybody else has the same question in their mind, I would look up the agenda, but I think it's sometime later this afternoon. So, great. Thank you so much, guys. Enjoy your lunch. I don't want to get in the way.